Good morning, students. Today we will discuss Gauss equations, which are of great importance in the study of surface theory. So, the following three partial differential equations, R11 is equal to Ln plus Lr1 plus lambda R2. Second, R12 is equal to Mn plus Mr1 plus mu R2. R22 is equal to Nn plus Nr1 plus mu R2. Here capital L, M, N, these are the second order fundamental magnitudes. R1 is the partial derivative of vector R with respect to u, and R2 is the partial derivative of vector R with respect to v. R11, R12, R22 are second order partial derivatives of vector R. L, M, N, lambda, mu, nu, these are suitable functions of E, F, G and their partial derivatives with respect to u and v. These are given by L is equal to 1 upon 2h square G E1 minus 2f F1 plus f E2. M is given by 1 upon 2h square into G E2 minus f G1. N is given by 2g F2 minus g G1 minus f G2 divided by 2h square. Lambda is given by 2e F1 minus e E2 minus f E1 divided by 2h square. Mu is given by e G1 minus f E2 divided by 2h square. Nu is given by 1 upon 2h square multiplied with e G2 minus 2f F2 plus f G1. These six coefficients L, M, N, lambda, mu, nu are called Gauss coefficients, and these three equations are called Gauss equations. In the matrix form, Gauss equations can be written as, in the left side we have the column vector consisting of R11, R12, R22. On the right side we have the matrix having L, L, lambda in the first row, M, M, mu in the second row, N, N, nu in the third row, and this matrix is multiplied with the column vector consisting of the vectors N, R1 and R2. N is the normal unit vector to the surface. R1, R2 are tangential vectors, which denotes partial derivatives of vector R with respect to u and v partially. And E, F, G, these are the fundamental magnitudes, as we already discussed in chapter 4. E is given by dot product of R1 with itself. F is given by dot product of R1 with R2. G is given by dot product of R2 with R2. Suffix 1 and 2 denotes partial derivatives with respect to u and v. For example, E1 means partial derivative of E with respect to u. F1 means partial derivative of f with respect to u. G1 means partial derivative of g with respect to u. E2 means partial derivative of e with respect to v. And F2 means partial derivative of f with respect to v. G2 means partial derivative of g with respect to v. Now let us find these Gauss coefficients. Now, by definition, because second order fundamental magnitudes L, M, N, these are the resolved parts of the vectors R11, R12 and R22 along the surface normal N. So by definition, L is given by dot product of R11 with N. This is the resolved part of R11 along the surface normal. This is the resolved part of R12 along the surface normal, and this is M. And this is the resolved part of R22 along the normal surface normal. So the N is given by R22 dot N. So we can express R11, R12 and R22 in the following forms. R11 can be written as Ln plus Lr1 plus lambda R2. R12 can be written as Mn plus Mr1 plus mu R2. and R22 can be written as Nn plus nR1 plus nu R2. Now we find the values of these 6 coefficients L, M, N, lambda, mu, nu in terms of the first fundamental magnitudes E, F, G and their partial derivatives with respect to U and V. So firstly, to find L and lambda, now we will take the dot product of this equation 1 with the vectors r1 and r2 respectively. Now this equation is r11 is equal to ln plus lr1 plus lambda r2. Taking dot product with r1 on both sides, this will become r1 dot r11, this will become l into r1 dot n plus l into r1 dot r1 plus lambda into r1 dot r2. Now because r1 is tangential vector to the surface and n is the normal unit vector to the surface, so r1 dot n, that will become 0, r1 dot r1 is E, r1 dot r2 is F. So this equation will become r1 dot r11 is equal to L into E plus lambda into F. Now taking dot product of this equation with r2 on both sides, so this will become r2 dot r11, this will become L into r2 dot n plus L into r1 dot r2 plus lambda into r2 dot r2. So from here again, because r2 is tangential vector to the surface and is normal unit vector to the surface, so r2 dot n will be 0 and r1 dot r2 is F, r2 dot r2 is G. So this equation becomes r2 dot r11 is equal to LF plus lambda G. Now let us express the vectors r1 dot r11 and r2 dot r11 in terms of E, F, G and their partial derivatives with respect to U and V. Now partial derivative of r1 square with respect to U. r1 square means r1 dot r1, so its partial derivative with respect to U, that will become 2 into r1 dot r11. Now this is E, so partial derivative of E with respect to U divided by 2 is equal to r1 dot r11. So from here r1 dot r11 is given by E1 by 2. Now if you find partial derivative of F with respect to U, F is r1 dot r2. So by using product rule of differentiation of dot product of the vectors, this will become r11 dot r2 plus r1 dot r12. So from here we can find the value of this dot product. This is r2 dot r11 is equal to partial derivative of F with respect to U minus r1 dot r12. Now partial derivative of F with respect to U, that is F1, and this is half of partial derivative of r1 square with respect to V. Now from here r2 dot r11 is equal to F1 minus half of this is E2. So we can substitute these two values in the equations second and third. We get the equations LE plus lambda F is equal to half E1 and LF plus lambda G is equal to F1 minus half E2. We can solve these two equations for L and lambda. So the value of L is given by GE1 minus 2FF1 plus FE2 divided by 2H square, and the value of lambda is given by 2EF1 minus EE2 minus FE1 divided by 2H square. Till yet we have obtained the value of lambda and L. Now we find next the value of M and V. As in the first case, we have taken the dot product with vectors r1 and r2 on both sides of the first Gauss equation. Now we take the dot product of r1 and r2 in the second Gauss equation, which is the equation r12 is equal to mn plus mr1 plus mu r2. So in this equation, taking dot product with vector r1, this will become r1 dot r12 is equal to m into r1 dot n plus m into r1 dot r1 plus mu into r1 dot r2. And if we take dot product with R2 here, this will become R2 dot R12 is equal to M into R2 dot N plus M into R2 dot R1 plus mu into R2 dot R2. Now we can rewrite these two equations by using the same properties, because R1 dot N, that is 0, because this is tangential vector to the surface, this is normal vector to the surface, so their dot product will be 0. R1 dot R1 is E, R1 dot R2 is F. So this equation will become ME plus mu F is equal to half of partial derivative of R1 square with respect to V. Now partial derivative of R1 square with respect to V, this is 2 times R1 dot R12 and this is E2, so this will become half E2. From this equation we have, because R2 dot N, that is 0, R2 dot R1 is F, R2 dot R2 is G. So we get the value MF plus mu G is equal to half of partial derivative of R2 square with respect to U. Now because R2 square is G, partial derivative of G with respect to U, that is G1. So this will become half of G1. Solving these two equations, we get the value of M and mu, which are given by GE2 minus FG1 divided by 2h square, and mu is given by EG1 minus FE2 divided by 2h square. Now to find the last two coefficients N and mu, we take the dot product with vectors R1 and R2 on both sides of the third Gauss equation. Third Gauss equation is R22 is equal to N plus NR1 plus nu R2. If we take dot product with R1 here, this will become R1 dot R22 is equal to, this will become 0 and this will be N into R1 dot R1 plus nu into R1 dot R2. If we take dot product with R2, this will become R2 dot R22 is equal to, this term will be 0, this will become N R1 dot R2 plus nu R2 dot R2. Now R1 dot R2 is E, R1 dot R2 is F, and R2 dot R2 is G. So these two equations will become NE plus nu F is equal to F2 minus half G1, and this will become NF plus nu G is equal to half G2. Now we can solve these two equations to get the value of N and nu. N is given by 2GF2 minus GG1 minus FG2 divided by 2h square, and nu is given by EG2 minus 2FF2 plus FG1 divided by 2h square. So we have obtained the values of all the 6 coefficients L, M, N, lambda, mu, nu. These 6 coefficients are called Gauss coefficients or Christoffels symbols. So this completes the topic Gauss equations and Gauss coefficients.